Okay, for what we have on page 249, in case problem number 8, okay, so we have a quadratic function, and we have in the form of g of x is equal to the negative of the square of x plus 2, okay, followed by the addition of 4. And now for this particular quadratic function, okay, we say that is going to be in line, okay, with what we have in the case of g of x is equal to f of x. And again, we have the vertex form where upon we have a times the quantity of the square of x minus h followed by k. And in terms of, once again, laying the groundwork in terms of like what we did earlier with the previous example, okay, so if we establish what the coefficients are, so a is going to be at -1. For h is going to be the 0 of x plus 2, so in this case h is going to be at -2, and we have for the value of k, okay, that will end up at 4. Now if we do the same exercises as what we had earlier, okay, now for the value of a, okay, a is equal to -1, and if we focus upon the direction to which, okay, the graph is going to open, okay, so we have that a is negative, and so we have in consequence that the graph of g of x is going to open downward. For what we have regarding the axis of symmetry, okay, in the general form we have x is equal to h, and with the value of h specified at -2, the axis of symmetry we have x is equal to -2. And as for what we have in the vertex, again, the general coordinates we have h and k. And for this particular function, okay, that translates to -2, 4. For the x-intercepts, once again, we're looking at setting y to 0, or in this case g of x to 0, as we are looking at solving for x. Okay, so we have 0 is equal to the negative of the square of x plus 2 followed by the addition of 4. And as we isolate, okay, the variable expression, so we can take away 4 from both sides. So we have -4 is equal to the negative of the square of x plus 2. And we can have just the negative signs to cancel out. And we can just do a commutative switch, okay, and have the x expression to the left. So we have that the square of x plus 2 is equal to 4. And again, utilizing the square root property of equality, we can go from the square of x plus 2 to x plus 2 is equal to plus or minus, okay, the square root of 4. Square root of 4 is 2, so we have x plus 2 is equal to plus or minus 2. And so taking what we have in the case of x, okay, so you have at the lower end, x plus 2 is equal to -2. And we have at the upper end, we have x plus 2 is equal to 2. So we have for the values of x, okay, we have -4 at the lower end, and at the upper, we have x is equal to 0. So there will be two x-intercepts, okay, which we have at x is equal to -4 and x is equal to 0. So taking what we have, if we write in coordinate fashion, okay, so we have at -4, 0, and the origin. In the case of the y-intercept, okay, so for the y-intercept, we're looking at where the graph is going to touch or cross the y-axis. And still working with the same function. So in this one, we're now solving for y as x is set to 0. So we can say that for y is equal to g of x, as x is set to 0, we have y is equal to g of 0. And plugging in 0 for x, now we're going to have the negative of the square of 0 plus 2, followed by the addition of 4. And so we have y is equal to the negative of the square of 2, not the square of negative 2. There is a difference. And the square of 2 is 4. However, we are taking the opposite sign, and negative 4 plus 4 comes out to 0. And it will follow that, okay, for the y-intercept, we'll end up at the origin. And the origin, okay, is the distinct order pair where we have this to be both an x-intercept and a y-intercept. Now, in terms of taking what we have and graphing, and so just taking once again, now we'll just go ahead and set up, okay, the axis of symmetry. Alright, once again, we had identified the vertex as negative 2, 4. And since the graph is opening downward, okay, the vertex is going to be the maximum. Okay, and in terms of the intercepts, again, we have at negative 4, 0. And also we have the origin. And we'll just leave it with these 3 points. Okay, so we'll have the parabola to open downward. Okay, and so we have the graph of this function, g of x, again, which is equal to the negative of the square of x plus 2, followed by the addition of 4. Now, in the case of what we have, right quickly, and now there have been various ways upon which we can solve for quadratic equations, and let me give you just an introduction. And we have, with regard to converting from standard to vertex form, again, we have with the standard, okay, so we have, once again, f of x is equal to ax squared plus bx plus c. And for the vertex form, again, same function, different layout. So you have a times the quantity of x minus h raised to the second, followed by the addition of k. And let's say that in terms of converting. Okay, let's say that if I were to determine the vertex and we'll say that we have the vertex of f of x is equal to x squared plus 8x plus 20. Okay, so for x squared plus 8x plus 20. Okay, so this is going to be the standard form. And tell you what, so we have in the process. Okay, so if I start out with the standard form, so I have f of x is equal to x squared plus 8x plus 20. And in creating the pathway to arriving at the vertex form, first of all, we do not have a squared trinomial. So for what we're going to do is that we're going to separate the variable terms apart from the constant at the end. And then for what we have in the process, we're going to have what is going to be referred to as completing the square. And for what we have here, so inside the parentheses you have a square term and a first order term in the independent variable. And to complete the square, we're going to form what is referred to as a squared trinomial. And in the process, we're going to take half of the first degree x term coefficient. In this case, we have 8, so we're going to take half of that and also square. So half of 8 is going to be 4, and 4 squared is going to be at 16. And in terms of what we're going to do with 16, again, we're going to add this to x squared plus 8x. But we want to keep everything in balance. Okay, so if I add 16, right now I'm going to have x squared plus 8x plus 36, but to keep it in balance. Now at the front, I am adding 16, but to keep it in balance, I want to take away 16. And so for what we have, and looking at the next phase in the arrival at the vertex form, so we have x squared plus 8x plus 16 quantity. 20 minus 16 is going to be at 4. And for arriving what we have in vertex form, okay, now from x squared, we have the square of x. And in terms of what I have upon how I got to 16, I squared out positive 4. So I have plus 4. And so we have, for the vertex form, so we have the f of x is equal to the square of x plus 4, followed by the addition of 4. And in terms of the values that we have, again, for the leading coefficient, that's just going to be at 1. And again, h is going to be, say, the 0 of x plus 4, so we have negative 4. K value is going to end up at 4. And with h and k, we can state that the location of the vertex, that is the point from which the graph of f of x opens, is going to be situated at negative 4, 4.